I'm David Barter, this is Stephanie Wiria-Harjit, and this is Ken Klock. Our project is called Point Locus. It's a wearable GPS vest for the visually impaired that communicates directions through vibrations located on the triceps here. It's a very simple language of left or right. Once the user gets the left or right signal, they stop and rotate in that direction until they get the vibrations from both as an indication to move forward. They also get a signal of forward, both of them at the same time, about every 20 seconds to reassure them that they're going the right direction.
Okay.
The idea is that it will increase the independence of visually impaired users in their travel because it allows them to do long distance navigation rather than relying on someone with sight to guide them or on transportation that may or may not be available to take them from point A to point B.
Right.
It uses voice recognition to allow the user to tell the system where they want to go, and then it calculates a path from point A to point B, where you are to where you want to go, and communicates that path through the vibration signals to guide them turn by turn to their destination.
So it actually uses voice commands.
Yes, it does.
Okay, so tell me a little bit about that. So you say something out loud like to the right, or do you say something more specific?
Right now, the voice recognition devices uses just simple commands like such as forward, backward, up and down. Or sorry, not forward, up and down, left and right.
Okay, up and down would be really cool if we had a jetpack on here, right?
So
I think that's the next phase. You need to have a jetpack.
Yeah, absolutely. Up and down.
Yeah.
Okay, so the voice recognition device just takes simple commands at the moment, such as forward, left and right.
Okay.
What that does is just indicates the information to the vest to showcase the signal.
Well, we're ideally hoping that once we get better voice recognition technology, that it'll be able to recognize what people are saying as a destination and feed that into the system.
Oh, awesome.
Then it will use that as the destination and calculate where you are and create a path in between the two.
Oh,
Then that will be the basis of what it tells these vibrators to do and when. The GPS will constantly have a perfect location or a perfect idea of where you are.
Okay.
And then it will just vibrate once you need to change your direction, and it'll keep on telling them that they're going the right direction every 20 seconds or so.
What about things that get in their way? Is there any plans for dealing with that? Or?
For immediate space navigation, the visually impaired are already very, very good at doing that.
Okay.
It's designed to work with their natural adaptations, the cane or a guide dog. And with those at their side, they can easily navigate through the immediate space just fine. It's just long distance navigation, getting from point A to point B to point C that they can't actually do because they can't mentally picture in space where their destination is.
Oh my gosh.
And they cannot memorize space because they can't see it. They have to feel it, but if it's so huge, it's impossible to feel it all. So they just need a helping hand directing them in the proper direction.
Oh
Everything else is taken care of by their immediate space navigational tools like the cane or the guide dogs.
Oh, this is perfect. I totally didn't get that. That's awesome. So that's really what makes this unique, is that you're taking a much wider view of things. So tell me a little bit about, in terms of programming, the things that you guys are using. You want to tell me a little bit about that?
Sure, I'll try my best. At the moment, we're using Arduino, the microcontroller, to control the vibrations on these two vibrating pager motors.
Okay.
We have a GPS module that's also connected to Arduino that does give us latitude and longitude.
Okay.
But what we're looking for is someone to help us with the actual programming in terms of getting the space, getting like a Google Maps onto this type, like a Google Map type of thing onto the Arduino. But it might be having something even more technical, more complicated than that.
Okay.
And that's what we're looking for.
So you're talking about maybe somebody could go to a website and program in places that they want to go, something like that. Eventually, down the road.
Eventually.
But for right now, just being able to hook this up to some sort of directions via Google Maps, being web-based.
Web interaction is a possibility since the visually impaired are able to use screen readers to navigate websites.
Absolutely.
So there's that possibility. The only problem with that might be that it'll be a bit limited because you have to be at a computer, you have to be at home, or you have to be at a computer on the road. If you want to change the destination when you're on the fly traveling, it may not be as easy. And the visually impaired have great difficulty using smartphones because they're so touchscreen based and things like that. There's very little
There's
accessibility.
sensory feedback,
Yeah,
right.
There's very little accessibility in smartphone, but that is something that we're looking into.
You guys did some user testing?
Yes, we did actually a few months of user testing itself, and through those user testings, we figured out where to put the sensors best. So the first idea we had was actually a bell, but through the user testing, we realized that not everybody's comfortable with it.
Okay.
And because
so they weren't comfortable with a belt? Did you?
it's just because the vibration system, because they're so close to each other, so it depends on a user's torso.
Oh,
sometimes they get mistaken of which motor is actually vibrating.
Oh, I see.
So then we tried on the wrist idea as well as the triceps, and triceps works best.
Okay.
It's sensitive as well as it's easy to put on into like a vest. So
That makes sense.
Yeah.
That makes sense.
So we did user testing within ourselves with the people that have the impairment itself. We paired up with the Canadian National Institute of the Blind. They helped us a lot with giving us feedback as well as user testing it.
Oh, that's awesome.
Yeah.
Very cool. Now, tell me a little bit about, this is a pretty interesting idea. So I'm a little bit curious what inspired you guys to create this?
I think it started with a simple recognition that the visually impaired are a very good user group to do a design project for. We felt that they were being left behind by technology quite a bit, We hadn't really investigated anything at that point, but we were thinking that there's not really that many technological breakthroughs for the visually impaired. And with the way technology is working right now and the direction it's going, it seems so visual, like with smartphones, for example, and touchscreens. We were thinking, what do the visually impaired have? What can we do for them?
Okay.
It was a group with a very obvious need, and that's the sort of thing that really can kick off a design project.
Right, that makes a lot of sense. Now, you guys are in a program, and that probably encourages you to find stuff like this. Is that true? Yeah?
Yep,
Can you tell me a little bit about that?
We're part of the School of Interactive Arts and Technology at Simon Fraser University in Vancouver, British Columbia.
Okay.
It's a program that has several concentrations, including interaction design, which is what we do. It's all focused about designing interactions and finding out things through user testing and studies in as low-fi a way as possible and as low cost. Building for something that is targeted towards groups with actual needs that are very localized and specific, but with an ill-defined problem that needs exploration and many bits of testing here and there.
Yeah. Okay, so tell me a little bit, just real quickly, like next steps. So tell me what you want to do next. What's the next phase?
The next phase is perfecting our technology. What we've done so far is getting the interaction in place and having a solid platform of interactions to build on. Now we just need the technology to resolve itself. We feel that the technology is out there, but we just need to find it. We need to find people that can help us with it. We're not technical experts. We're interaction experts.
Okay.
So the problem is just we need better technology and we need to be able to program it. So that's the kind of.
How can people contact you if they wanted to work with you guys on this?
They can contact us with our email right there, or visit our website to find more information on us.
Oh, that's awesome. I'm so glad you guys have a website. Yay! Point Lucas. Awesome. Thank you guys.